We are on the bottom of page 33. Kinetic energy. Kinetic energy is the energy possessed by an object that is in motion. Kinetic energy increases as the mass and the velocity of the object increase, and can therefore be calculated using the equation Ke equals 1/2 mv squared. We might even see this equation written down as Ke equals mv squared on 2. It's the same thing. Multiplying by a half or dividing by 2 is mathematically the same thing. This is very important to remember for later on when we are going to tackle questions that require subject of the formula. Moving on to page 34, where we will find a couple of worked examples. Number 1. An elephant walks with a velocity of 5 meters per second. Calculate the elephant's kinetic energy if its mass is 2000 kilograms. From the question, we can see that its velocity is 5 meters per second. Its mass is 2000 kilograms, and we have to calculate the elephant's kinetic energy. So we should start off from the equation. Ke equals 1/2 multiplied by m multiplied by v squared. Let me remind you that sign means to the power of, the one highlighted in blue. Plugging in the values, we will get Ke equals 1/2 times 2000 times 5 squared, which we can rewrite as 1/2 times 2000 times 25, because 5 squared is 25. All of that will give us a value of 25,000 joules. In this case, since there are only 3 zeros, it does not really make that much sense to convert it into standard form. You can also write 25 kilojoules instead. Both will be accepted. Question 2. A car of mass 1000 kilograms travels with a speed of 30 meters per second. Calculate the kinetic energy of the car. So we were given its mass, its speed, and we have to calculate the kinetic energy. Once again, starting off from the equation, so Ke equals 1/2 times m times the velocity squared. When we plug in the values, we get 1/2 multiplied by 1000 multiplied by 30 squared, which can be rewritten as 1/2 times 1000 multiplied by 900, because 30 squared is 900. All of that will give us an answer of 450,000 joules. This should be converted into standard form. So that will be 4.5 times 10 to the power of 5 joules. Question 2b. The car now slows down to 10 meters per second. Calculate the change in kinetic energy. So the mass has remained the same, so we should not have a problem there. The speed has changed from 30 meters per second to 10 meters per second. Now, this can be a very tricky question, because what we're being asked here is to measure the change in kinetic energy. So not only do we have to find the kinetic energy at 10 meters per second, but we have to minus the answer we will get with 10 meters per second from the value we have just found. So we will start from the equation. Ke equals 1/2 times m times v squared. Plugging in the values, we'll get 1/2 times 1000 times 10 squared, which can be rewritten as 1/2 times 1000 times 100, which will give us an answer of 50,000 joules. But that is not all. Like I said, we have to minus 450,000 joules by 50,000 to find our final answer. 450,000 minus 50,000 will give us 400,000 joules, or 4 times 10 to the power of 5 joules. Question 3a. Using the equation for kinetic energy, make m the subject of the formula. In this case, we don't have any values to plug in. So we'll start off from the equation once again. Ke equals 1/2 times m times v squared. In this case, we have to get m subject of the formula, which means that we have to take the 1/2 and the v squared over to the other side. Now, in this case, a bit of a trick would be to group the v squared and the 1/2 together, so that we'll get ke equals v squared on 2 multiplied by m. It's still the same thing. This equation and this equation are exactly the same, because instead of dividing by 2 or multiplying by half, which I said already is the same thing, and then multiplying by m and then by v squared, we are taking it a bit of a different route. Dividing v squared by 2 and then multiplying by m. Now, as you know from algebra, whenever you take something across the equal sign, if it is a multiplication, it will turn into a division, and if it is a division, it will turn into a multiplication. So basically, v squared on 2 will become 2 on v squared. Things are going to flip. That will give us ke times 2 division by v squared equals m. Now, if we wanted to tidy this up a bit more, we would write it as follows. M is equal to 2ke divided by v squared. The 2ke is coming from ke multiplied by 2. So there we're grouping things to make them look a bit better. Question 3b. This time we've been asked to make v the subject of the formula. So once again, we're going to start with the same steps. So first, we'll start from the original equation. Ke equals 1/2 times m times v squared. We will group m with 1/2, which will give us m on 2 multiplied by v squared. Taking m on 2 onto the other side will give us 2ke divided by m is equal to v squared. Now, once again, we were asked to get v subject of the formula, not v squared, which means that in order to get rid of the power of 2 on this side, we have to square root the other side. And that will give us v equals the square root of 2ke divided by m, which can also be written like this. V equals the square root of 2ke divided by m.